Hey everyone, welcome to my channel. In this video we are going to learn how to quickly set up your Raspberry Pi for the first time and create a simple project with it. We will learn how we can remotely control Raspberry Pi with Windows or Mac. We will be using an LED light and a push button so that we understand both inputs and output devices. I upload videos on a weekly basis, so don't forget to subscribe and hit that notification bell so you don't miss out on any of the upcoming videos. So let's get started. So let's start with the introduction to Raspberry Pi. Now Raspberry Pi is a lot of the times compared with Arduino. So let's have a look at how these two are different and how they are similar. So Raspberry Pi is itself a computer. We can call it a mini computer, whereas Arduino is a controller. So the first main difference is that Raspberry Pi has a microprocessor, whereas Arduino has a microcontroller. Now both of them have GPIOs, which are general purpose input and outputs. But with Raspberry Pi you cannot have analog inputs, whereas with Arduino you can have both analog and digital inputs. Now the Raspberry Pi works on 5 volts, whereas the Arduino can run between 5 to 12 volts. Now with Raspberry Pi we have built-in Wi-Fi and Bluetooth, whereas with Arduino we have to connect external Wi-Fi or Bluetooth modules. Now when working with sensors, Raspberry Pi is a little more difficult, whereas Arduino is much more simple when talking about sensors. The Raspberry Pi is easy for computer vision applications, whereas Arduino is much more difficult because you need external hardware to connect with Arduino in order for the camera and the extra computational power. Next we are going to have a closer look at the Raspberry Pi. So here we have the Raspberry Pi 4, which is very similar to the Raspberry Pi 3. So if you are following along with Raspberry Pi 3, it should be pretty much similar. So first of all we have the SD card, then we have our power slot, and then we have our HDMI ports along with the stereo port. Now we can also connect 4 USB devices along with an Ethernet cable. So looking inside the components of our board, we can see that we have our GPIOs, then we have our processor, we also have a RAM, then we have the Ethernet controller and the USB controller, then we have the Wi-Fi and Bluetooth module, the display port, and the port for our camera. First we will head on to the Raspberry Pi download section and we will download Noobs. You can download the torrent or the zip format. Now if there is something already on your SD card, we are going to format it using an SD card formatter. The link to this will be in the description. You can skip this step if you have a new card. Now we will extract our zip file contents to our SD card. Then we will insert the SD card to the Raspberry Pi. You can see I have added some heat sinks for cooling purposes. I will also be using an external casing that will allow a 5 volt 40 mm fan to be force fitted. This helps in keeping the Raspberry Pi cool, and trust me, it makes a lot of difference. Now we can insert the HDMI and the power cable. Once the Pi starts, it will ask us to choose an operating system. Now we will choose the Raspbian. The installation will take about 10 to 15 minutes, and then it will reboot and start the setup dialog. Here we will select the country. For the password, I will put in just one. If your screen has black borders, check this dialog. Now we will connect to the Wi-Fi. Lastly, we will update our software. Once done, we will restart. So now there are two ways of running your Raspberry Pi. Now one is to use it as a PC, so you connect your monitor, you connect your keyboard and mouse, and you run it as a standalone PC. Now the other method is by using a different PC to control your Raspberry Pi. Now for that, if some of you would like to use that method, Raspberry Pi has a built-in software, a native software that they have already installed. So you can go to Raspberry Pi start menu, and then you can go to preferences and then Raspberry Pi configuration. Now in this configuration, we are going to go to interfaces, and over here we are going to enable VNC. So we are going to say enable, and we will press OK. So once that is pressed, on the top right corner you will see that a new icon of VNC has appeared. So you will double click that, and here you will find your IP address. So this is the IP address of my Raspberry Pi. What you have to do is you have to note down this IP address, and then we will go to our other computer that we want to control our Pi with, and then we will install the VNC player over there, the VNC viewer, and then we will input this IP address. Now we will head on to the VNC website and download the VNC viewer. The link is in the description. Then we will install and open it up. Now we will use the IP address that we saw on the VNC in the Raspberry Pi. The default username is Pi, and the password we already set as 1. And there you go. Now we can access our Raspberry Pi remotely. So let's have a look at the environment. At the top we have our taskbar. Now you can add and remove things on the side here, and you can see our Wi-Fi is connected, and we have a Bluetooth option as well. Then we can go to our menu, and we can see that we have some programming editors. We have our Internet Explorer, which in this case is our Chromium web browser, which is very close to Google Chrome. Then we have some sound and video. So here we have our VLC player, which we can use to play some videos. And then in the preferences, we have our Raspberry Pi configurations. Now, the first thing we are going to do is we are going to add the temperature of our Raspberry Pi so we can monitor it. So we will right click on the taskbar. We will go to add and remove panel items. We will click on add, and over here we will look for the temperature monitor. So we will click on that and we will add it to our taskbar. So now it's on the very right hand corner. So what I like to do is to move it up a little bit so we can see it like that. Okay, so now we can see that it's showing green, and it is showing that it's 39 Celsius, which is very good. And the reason for that is that I am using the cooling fan and the heat sinks as well. If you don't use that, you might get something like 60s or 70 degrees Celsius. So the next step we are going to do is we are going to open up our terminal. Now in the terminal we can write different commands to actually run, and this is not very intuitive. It's basically without any graphical interface, and this is one of the reasons why a lot of people are afraid to use Linux systems or Raspberry Pi. So the first thing we will do is we will write sudo, and the sudo, what it does is it gives administrator privileges. So we will write sudo apt-get, and we will write update. Now this will update and look for any updates if there are any available. So then we are going to write sudo apt-get, and this time we will write upgrade. And we can see that we don't have anything to update or upgrade, so that's a good thing. So next we are going to look at our Python. So this is what we will be using in our Raspberry Pi. So to see if we have Python properly installed, we can write Python, and we can write / and version. So this will tell us that we have the Python 2.7 16. Now this is the old version. This is Python 2. What we are going to use is Python 3. So we will write Python 3 and then again / version. Python 3. So this will give us 3.7.3. So that is good. So we have the version 3.7. So now we are going to write our first program. So first we are going to go to our main menu. We will go to programming and we will open up our MU editor. Now here we will make sure that our mode is set to Python 3. So we will press OK, and now we are going to write our first code. So in order to test it out, we will first print. So we will write print and we will say hello world. Now we can simply press the run button to actually run it. Before we do that, we are going to save it. We will go to Pi, desktop, and on the desktop we will create a new folder and we will name it my files. Let's make that F capital, and we will open that, and inside we are going to write LED code. So we will save this. Now you can see that in our console we are getting the result as hello world. So for running the LED, we are going to import a package by the name GPIO0. So we will say that from GPIO0 we are going to import LED. So as you can see, the MU editor actually helps you find what you're looking for. So it's telling you that these are the methods or functions or whatever it is. This is available within this package. So here we can see we have the LED. So next we are going to import time. So we will say that from time import sleep. So we are going to use this for the delay. Now our main aim is to blink the LED, so we will turn it on for 1 second and we will turn it off. So first of all, we need to define our pin number. So we will say that our LED is equals to LED that is connected to pin number 17. Pin number 17. Okay, let me go back and let me show you something. LED, and when I write the bracket, you will see the definition of this function or method. You can see what it does and how you can use it. So for example, here you can see the following example will light up the LED from GPIO 0 import LED, and then LED is equals to LED, and you are writing the pin number inside. So this is what we are going to do. We are going to write, for example, we'll keep the same example as pin number 17. And then we are going to create a loop. So we will write a while loop. While true, we are going to write that we want to turn the LED on. So we are saying LED dot on. And then we will sleep for 1 second. Sleep for 1 second. And then we will turn the LED off. And then we will sleep again for 1 second. So this should turn on and off our LED light. Now, before we actually go and run it, we will write a print statement as well, just to make sure that our code is working properly. So we will write here on, and then at the bottom, we will write here off. So if we run this now, you can see after every second our state is changing and we are turning it on and off. Now let's see the result on our Raspberry Pi. So now we are going to see how we can detect an input from a button. So we will create a new script, and here we are going to write again from GPIO 0, we are going to import button, and from time we are going to import sleep. Now, in order to declare our pin number, we are going to write button is equals to button, and we are going to define our number. So for example, in this one, we are going to use the pin number 2. So now we want our value to be displayed continuously, so we will write it in a while loop. So we will write while true, and then we are going to print out the value of our button. So we will say print, and then we will write button dot is pressed. So we are just checking that whether our button is pressed or not, so it should return us true or false. Now this will happen really fast, so we need to add a delay. So we will say that sleep, let's add 0.01, and now we can run this. So right now it's saying false, and when I press the button it says true, and when I release it says false again. So this is how you can get the input from a button. So lastly, we are going to combine these two codes, and whenever we press the button, we are going to turn on the LED light. So let's see how that can be done. So we will create a new tab, and here we are going to copy from our previous code. So we are going to copy these two. And here what we can do is because we are importing from the same package, we are importing the button and the LED, we can simply put a comma and we can write button. So it will import both of them. Then we are going to declare our LED and the button. So we will copy the LED part. And then we have the button part. And now we need the while loop. So we will copy it from the button. So here we are saying while true, print the button is pressed. So what we will do here, we will remove the print and we will say if our button is pressed, then we are going to turn on our LED. So we will say LED dot on, and then we will say else LED dot off. So let's run this and we will say button, let's say LED button code, and now when I press it, the LED light turns on whenever I push the button. So this is it for today's video. I hope you have learned something new. If you have any questions, you can comment them below. Don't forget to subscribe and hit that notification bell. And if you like that video, give it a thumbs up, and I will see you in the next video.